Good morning.
Good morning. We couldn't find the e-learning assignment yesterday. The day for yesterday.
What do you mean you couldn't find the assignment?
Yeah. Then you
Good
post
morning, Doc.
We didn't do an assignment.
so wasn't nothing on e-learning that we had to do?
Nope. There isn't. So there isn't really anything on e-learning that we're going to do at all.
Oh.
No hate to e-learning, I guess, but it causes issues because it's not always up. It's very intermittent. So I don't really want to have any time sensitive anything rely on that.
That's good.
So assignments are all going to be pretty much through WebAssign. The thing that was up there, let's see, was, where is my, so one thing that was up there was this moving online document, and that's what we went over on Wednesday. If you haven't looked at it, I suggest you do. And there are a couple extra little things that I have added. So like I said, I highly suggest you check that out. And actually, I want to pull it up. So one thing that I added was a link for my YouTube channel. I expect all of you to subscribe to me. Oh, I have no views yet? What? That's sad. So when you go to my YouTube channel, I have playlists set up for each of my different classes. So you can go, and obviously the only one that's currently up there is the one from Wednesday, but you can go up there and play this meeting off of online. So if you missed something, if you want to go back and review something, that is where I suggest you do it. But that link did get added, and I also emailed it out to everybody. So let's see. All right. Give everybody another minute or so to pop in. Let's see. Any questions or comments before we get started in a minute?
Good morning, Doc.
Good morning. How are we doing?
Caleb.
Good.
I'm glad everyone sounds so excited to be here today. Let's see what time got. All right. Okie doke. Well, we will look at what we're going to be running today. So if you want to know the breakdown of generally how we're going to be moving, this is kind of what we're looking at. We're going to do a little bit of a step back and review for today. But we will be doing our first online test. Will be open next week. And as we discussed, you'll have a couple attempts to it. And it'll be open for a few days. So there's not a huge time crunch for it, but it will only be open for the next week. And I'll go over that a little bit more in depth when we get into it next week. But for now, like I said, we're going to be doing, kind of a little bit of a review and a little bit of a feeling out how this whole process is going to work with the online e-learning deal. So in our books, we have been doing 5.4 is kind of where we ended off before the break. So we had these sum and difference formulas for sine and cosine. And then we built the tangent ones out of sine and cosine. And we also looked at, multiple angle formulas. And we built these out of those addition and subtraction formulas. So I just saw this question. All of the homework should be open now. So if you look, all of the due dates are 5/3. And this isn't all of the homework. This is all of the homework through the end of this section. There might be one or two more added toward the end, depending on where we get to. But all of the homework has been opened and extended to 5/3, which is the Sunday before finals week. So that's the all assignments, like I said, are opened back up. Good questions. Yeah. So let's look at our old notes, shall we? So yeah, we started with sum and difference formulas, sine plus or minus, cosine plus minus, and they gave us these. We applied those, but then we also derived the tangent plus minus formula, which here in the notes, again, these are in the book, but this is what they are for where they come from, I guess, is the better idea. So after talking about the sum and difference formulas, we talked about the multiple angle formulas. Remember, all of this trig stuff is all about going from a more difficult, some might say ugly version of a problem, and turning it into a simpler version. And if you have anything that isn't just an angle or like a single variable inside of the function, sine, cosine, whatever, when it's not just sine of theta or cosine of theta, it gets very awkward to deal with when you're talking about solving, and when you get into calculus, taking derivatives, integrals, all the stuff you do in calculus becomes much harder when you have more complicated things inside of the function. So that's one of the main goals that we have in this section, is taking functions that look, they don't look that difficult to us at this point. So sine of that doesn't look that much more difficult than just sine of one of them. But when you start doing calculus on it, it turns out it is. So that's what we're doing here, is we're trying to simplify or get individual pieces by themselves. So with the plus and minus formulas, the answers we end up with are a little bit more involved looking, but they are actually easier to deal with in calculus. So each of these is just sine of a single thing, cosine of a single thing. So that's the whole point behind all of this stuff. So keep that in mind as we go through. Those were just some examples we did. And then we got to the multiple angle formula stuff. So the way we started dealing with multiple angles is we started out rewriting it as a sum formula. Sine of 2 times theta is really just sine of 1 theta plus sine of another theta. And you apply that rule that we talked about previously and simplify some things, and you get that sine of 2 times an angle is 2 times the sine of that angle times the cosine of that angle. The cosine one is a little bit funkier looking. It actually has a couple different ways you can write it, but cosine of 2 times theta is cosine squared of theta minus sine squared theta, or you can use this one or this one. So this is just the stuff that we went over before the break, and don't worry about that stuff. That was an aside type thing. But we just started playing with these multiple angle formulas. Yeah. So where we're going next, we did sum, difference, and we talked about the cofunctions and double and half angle identities. So now product to sum and the sum to product is where we are kind of jumping into. So this is just the end of chapter 5.5. And these are the basic identities that we're going to be playing with. I'll let you guys look at them for a second.
That's 5.5.
Yes.
Okay.
Oh.
Mm-mm. The hell is going on with my phone?
Where you go?
All
Bro, my shit. Oh shit. I'm
right. So let's look at that first one for a second. And let's see if we can find a way to prove it. I'm going to use X and Y because I think they're easier to see. All right.
Oh, there's the board.
So we need to try and convert this into a product to some formula. Does anybody have an idea where we could start using the stuff that we already know? Is there anywhere that this has come up before?
bring it over.
Yes.
Yeah.
I'm sorry?
Bring it over.
Oh, wait.
Would you multiply the signs?
No, well, that's actually what we're trying not to do.
Okay.
Wait, but aren't they? Did it equal to 0?
No, so I'll write what
Yeah, I'll
it
just shut up.
equals,
I'll just shut up.
just shut up.
and
I'll just shut up.
we have to figure out how to get there. So
Dr. D,
yes.
where are you at?
What do you mean? Where am I at?
Are you at Allen?
No, I'm at home.
You have a whiteboard at home?
I do.
Wow.
This is
That's
my
dedication.
I actually have 2 whiteboards.
That's real dedication right there.
Taylor, hush
My,
up.
my dad,
Okay.
his office, they got sold to another company, and when they were breaking everything down, he's like, "Do you have any need for a giant whiteboard?" I was like, "I don't know, sure." And I just took it from him. It was like 3 years ago. I was like, "I'll find a use for it," and then Corona, 2019.
Well, it came in handy.
Who's laughing now?
That was clutch. So,
All right, my bad. You can continue.
No,
I was just
no,
curious.
you're fine. I'm happy to answer questions. If you hear screaming in the background, it's because my kids are downstairs.
Okay, good to know.
So no one's dying, I don't think. But you never know. All right. So this is what it does equal. We have to figure out how in the world do we get there? I know it's kind of tough to read. Let's see. I don't use the bottom of the board that much. Let's see if we... All right. Hopefully that's a little easier to see. So the place that we have seen sine multiplied by sine before in our identities is in the angle addition formula. So the angle addition one, we had cosine of x plus or minus y. What does that equal? Well, I rewrite it. So what does that identity equal?
Cosine plus, no, then cosine y. Is that it?
No.
All of it.
Wait,
So it's
wait.
the angle sum formula.
Wait, I don't know.
So minus plus sine x. Sine y. So this is the cosine angle formula. And this little bit on the end is what we want. This is what we need. Sine x, sine y. So if we solve this for that thing, we get minus plus sine, actually I'll do this in black. So what does that equal? We're solving the green one for this piece.
Would it be is it sine? No. You could combine the signs together?
Yeah, you're thinking about it too hard.
Would it be
I'm
cosine x
stressing
cosine
right
y?
now.
So if A equals B minus plus C, then minus plus C equals what?
B. Shut up, Solomon. I'm gonna mute myself.
You just take this thing and stick it over here.
A minus B?
Yeah, so my normally bad handwriting is going to be even worse. I'm sorry. Because it's a little awkward to move around. But I will try for you, I promise. All right. So, but we need just C. We don't need minus plus. because there's no minus plus up here. So how can we get minus plus?
So are you asking us like?
She just log out.
It's kind of a weird thing to think about, but these are the kinds of things skills that are going to be very helpful, because they're going to come up, and knowing what to do if you see something like this. So we know that minus C equals A minus B. We know that plus C equals A plus minus B. All right? So all I've done is I've taken this thing and converted it into two different. I used the minus version and the plus version, because that's what the minus plus means, is that there are two versions of that equation. One where you use the plus, or the top one, and one where you use the minus, or the bottom. So what you do is you subtract these two equations from each other. So I want to subtract the top one from the bottom. What do I get when I do that for this side? And I'll label them 1 and 2. So what we want to do is 2 minus 1. So what is the left-hand side of 2 minus the left-hand side of 1?
0.
Mm-hmm. They cancel out.
No. Write it out. This thing
They combine together, right?
minus this thing. So what is C minus negative C?
C2.
2C, yeah. Yeah, it doesn't cancel out. They add together. So you get 2C. But now what do we get over here? Well, we get this one minus this one. So this one is A plus minus B minus A minus. So what does that become?
Does the A's cancel out?
No, because they're different. This is A with a positive, with a plus in it, and this is A with a minus in it. Meaning A plus is this thing with a plus in it. Cosine x plus y. A minus is cosine x minus y. So those don't cancel because they're different. But these, hold on, things yelling at me. But these do cancel. So what you get is, oh, two C equals A plus minus A minus. So once we started writing in red, we actually haven't done anything weird yet. It's just adding, subtracting. We haven't really done multiply and divide yet. But we get to C. But we want C by itself. So divide the 2 over, and you get this thing. But now let's plug in what everything is. C is what we were looking for. It's sine of x, sine of y. A plus is cosine of x plus y. And A minus is cosine x minus y. Did I flip those? Yeah. The order should be opposite. I don't know where I flipped it. But you get this back out when you plug the definitions in. So this is just an example of taking relationships that you already know and just resolving. That's all we did, is we took this relationship, this one in green that we already know all about, and we manipulated it around to find the thing that we needed. So you end up with something that looks like that. But this is the idea, and it's all done the exact. It's all done the exact same way for all of these 4 sines, cosines that we have here. Let's see how I want to do this. Because we have a max time on our sharing. So in that one, we did sine of, I used x and y, but we did sine and cosine. I'm sorry, we did sine. But for the cosine one, we would use the same relationship. We would just be solving for the opposite piece. So for the cosine times cosine one, we would use this same relationship, but we would push this thing to the other side. So that's the long and short of it, is that we, oh, that's where I messed it up. So this is incorrect because the sign switches. We have plus on top, minus on bottom, minus plus. These two actually should have been opposite. That would have made this thing plus. But again, it's the same basic idea. I really wish I had my, my smartboard back, because this board gets pretty ugly looking pretty quick. But it's based off of that same idea. And it's this substitution thing that we did. I highly, highly, highly suggest that you guys start to play with it, because if you're going to be doing anything with math or computer science, it is amazingly helpful in solving problems, because solving this green thing is not easy. It's not. But solving the red one is easy. That's what we did. So solving the green thing, it looks crazy and ugly, but it's not that involved, because you can kind of mask some of the ugliness by putting it in those terms. So real quick, if we do the cosine one, so cosine x, cosine y. Well, we find that same little bit is in this green one. So we're actually solving this for b. When we do that, we get b equals a plus minus plus or minus c. So you can get the exact same idea here, but here you actually have to add them. So you get number 1 and 2. You get b equals a plus c, and b equals a minus c. So if you add these two things together, if you add the left-hand sides, what do you get?
I'm sorry, can you repeat that question?
So these are the two equations that we are using, and we add them together.
Dr. Dean, I think this thing gonna cut off on you in like 1 minute.
Yeah. Yeah, I think I have about a minute. So if you add them together, you get 2b equals a plus a minus.
Then you divide the 2 over and put it under the a's. Yeah.
So this equals cosine x plus y plus cosine x minus y over 2. So yeah, I'm probably about to get cut off.